Hello everyone, thank you for joining for today's call and this is the first session behind the Learn With Me series and thank you everyone for joining the today's call and hoping to get the foundation behind the generative AI. So today we're going to see the foundation behind the generative AI and we're going to see some little math behind it. I'm going to start with a lovely note from Anna Lovelace. Followed by that, we're going to see the overview of Amazon Bedrock by accessing the Amazon Bedrock Console with the from the AWS management console. So let's dive in. So something about me, my guys know about me. My name is Rahul, and I'm an AWS community builder in machine learning and generative AI category. And I've been part of an AWS Cloud Club for the last year as an AWS Cloud Captain for my university for the last 1 year from the academic advocacy team. And I've been keen in community programs and leading the AWS Cloud Club for the past 1 year. And I've started a community called Unknown Students. Why? Because I've been given the name for that and where the community's main focus is to give students a career pathway. And I'm also certified in CLF, GBA, history, and machine learning specialty. So my part of is writing professional blogs, and I've been a public speaker in AI and AWS community. And being a very huge fan of Hollywood series, but I watch rarely now. Being a very huge fan of Marvel and Harry Potter series. And you can connect me through my LinkedIn. You can type Rahul Gopal. You can able to see my face, and you can just hit me, connect me, so that we can talk each other through there. And if you want to do some any professional kind of communications, you can email me at rahulgopal@gmail.com. And if any of you can't able to attend the first session, or if you can't able to attend the next consecutive sessions, no issues, no worries. So you can follow me at the Rahul Gopal, subscribe to my YouTube channel, so that you can able to get the recordings of the for the series up to date. Right? Let's continue. So I said right. So I'm going to start this discussion with this lovely note of Ada Lovelace. So you guys know about Ada Lovelace. Ada Lovelace is the first scientific programmer who worked with Charles Babbage. So she's the first woman programmer. So what she says and what is being attracted towards is that everywhere you go, learn programs and start doing it. Please try to understand the mathematical science behind it. Okay, why? Because by applying the mathematical science behind each and everything, you can able to find the unseen relations between the x and y. Right? If you say the x is dependent on y or y is dependent on x, make sure to know about the relationship with the help of the mathematical science. So why I'm saying this is because okay, whenever you learn anything, please try to have some keen understanding behind it. Let you are learning any programming language or that you are learning any kind of concepts in AI, in DevOps, or any kind of stuff. Okay, please try to learn keen and please try to learn the foundation, the basics first. Okay, please don't directly jump into the topic, but because you can't able to take the foundations from the start, right? That's my advice too. So let's start with generative AI overview. I would say like generative AI has been booming for the last 2 to 3 years. I would say why because I've been a part of those things, right? But because in terms of natural language generation, natural language understanding, in terms of NLU and NLG, the generative AI is being in the peak, right? Say for example, ChatGPT has been boomed. Everyone's identifying activities and what can I say for other stuffs too, right? So understanding the context behind the text which has been given to you, it's very tough. Okay, but the AI model does it in a very quick fractions of seconds, right? So this is one of the journal, Wall Street Journal, and you might guys know about the Wall Street Journal. So they're given the prediction of 2024. So what they said is nothing but the generative AI will be the top of the town for the next decade. Not only generative AI come, they have said a lot of other point of view, but they precisely mentioned this as the first thing, like generative AI will be the top of the town for the next decade. Secondly, right from the professors from MIT, right, they said that there are a lot of powerful generative AI tools like ChatGPT and stuff like that. But they are giving you the difference between the traditional machine learning models, like say machine learning, deep learning, supervised learning, unsupervised learning. What it is different from the other types of artificial intelligence compared with generative AI. So they said that the activities performed by the traditional machine learning point of view is being outperformed by the generative AI. So this is one of the huge peak why because a lot of research has been coming daily, I would say. And if you want to be keen a part of those researches, you can follow my newsletter, the same name, which is Learn with Me newsletter. So it is a bi-weekly newsletter. I'll be posting 2 research papers per day on Wednesdays and Fridays, Wednesdays and Saturdays weekly. So subscribe that newsletter on LinkedIn. You can just hit my page. You can able to see my newsletter, and you can able to know about. So that's like I'll take one huge new research paper, jot down the points to make sure to understand in a very good, very clear way, so that you can able to see the exact things what is happening behind the paper. Right. So subscribe the newsletter too. So, but even though there is a lot of advancements happening behind this, what makes it generative AI, there are a lot of threats. I would say a deepfake issue, taking the image of other person, morphing it so that using for other non-relevant purposes, and sound engineering, taking the sound of other persons and morphing it. So, a lot of issues are happening. So, we need to use the AI responsible as much as responsible as we can. Please make sure to don't ask the AI to retrieve any PII format, like the personal identified information formats of the particular user or particular persons or particular companies, or stuff like that. So I would like to start this discussion today with a beautiful paper. As you guys know, this paper is nothing but this attention is all you need. I would say this is a stepping stone to generative AI. Why? Because this paper gave you the overview called the transformers. Okay, with the boom behind the transformers, we could able to see right now lot and lot of generative AI foundation models has been released. Okay, so though the generative AI foundation models release can be easily accessible through Bedrock, but we need to know about what is happening behind the basics, right? So first, when they released Transformers was very nominal approach, which was used to convert from one language to other language. Say I'm saying hi, how are you? Saying some language in English, I want to translate this. I want to convert this text to another language, into a Spanish, into a French. This Transformers has been used. So from that point of view, you could able to see how text generation and to be able to see the understanding point of view, context summarization has been pulled over into it. Right. So this is how. So transformer is an encoder-decoder architecture, as you guys might know about it, but you don't know how the encoder works and how the decoder works, and what are the different models comes under the encoder-only architecture and decoder-only architecture, followed by encoder-decoder architecture. So let us go much behind this in the next consecutive part. So first, let's start with how AI started in from the year 1949 to 2001. We could able to see it was before ML era, and we could be able to see the existence of natural language models. Okay, going back to 2008, we do have a multitask learning, and from the year 2013, we could able to see a model, a technique of word to vec and engrams has been released. So you might know about word to vec right now. It is also available in all the foundational models, or it could be an AI model, right? We can able to see the existence over here where the word has been converted into its associated numerical value. As you guys know, that AI model will not understand the string format. We need to convert that into an associated numerical value. So this is for the first step. Then followed by RNN and LSTM, my favorite thing, right? So from the deep learning perspective, recurrent neural networks and long short-term memory has been released to provide you an overview how the natural language text generation has been understood. So this is based upon the dependency with the previous text which has been generated. Say I'm gonna do like hi, how, or. So now the next text should be generated. It purely depends upon the previous text, and this text as we previously is usually depends upon this and usually depends upon this and goes on. To make sure to provide a huge a short-term memory for the model to understand, we could be able to see this process has been done by RNN, and the short-term memory has been provided by LSTM to provide it. So LSTM is a form of RNN, so we can able to understand those things. So with the existence of RNN and LSTM, right, from 2014, we could able to see the, or can I say, the overview of attention mechanism, where a focus to the important words in the natural language text has been given so that the model can be able to retrieve only the important text. Followed by that, what we are learning today is the transformers, the language, pre-trained language models, and after that is the boom of generative AI. You could able to see lot and lot of AI companies are releasing their own generative AI models, say Bird, say Amazon Titan, say Mistral AI, Mistral Meta LMRs, etc., etc., and stuff like that. So this is how the transformers model, like the encoder-decoder architecture will look like. So starting with the input, we could able to pass this input to the input embedding. So to keep a note that input embedding is nothing but converting the input words into an associated numerical values, right? So here JE, Zeus, HN, so it is a word. Now what happens is nothing but this will be automatically converted into some numerical values. So this is going to be called as embeddings, and this embeddings will be automatically pushed into the encoding component to encode the particular value. Before putting into an encoding component, a positional encoding will be done so that what depends upon the position of the character, position of the word present inside the embedding, it will be automatically featured. And you could able to see inside the encoding component, there will not be only one single encoding component, there will be multiple encoding components. So each and every encoding component will have two important things. One is self-attention, and the second one is feed-forward neural network. So we're going to talk a huge broader perspective of what we say self-attention and feed-forward, how it happens with some kind of vectors and matrices. Once this part is done, the encoding component output will be given to the decoding component to make sure that it also has the self-attention and the feed-forward, and we do have another extra part called as encoder-decoder architecture. Followed by that, you could able to see a linear layer with a softmax layer to find the probability of each and every output, each and every word output to find the best, what we say, best match for the particular, what we say, input is being given. So here, this is in one language, this is in another language in English, so that automatically based on the probabilities of the output, the best one has been chosen for the particular word which matches, so that the particular output has been given. So this is how the transformer model has been, what we say, built. So now let's talk about what encoder does. So as I already said, right? So you could able to see this is the complete sentence and the words has been split in terms of tokens. So here tokens has been split in based on words, but all the time the token will not be split based on words. There will also be a lot of issues. But let us see those issues in the next consecutive series, how to resolve those issues, stuff like that. So now you could able to see I have done an embedding to make sure to convert this words into one vector which consists of a numerical values. Now I pass this numerical values to the self-attention. Here in self-attention, we will follow a value matrix called as QKV matrix. Inside this QKV matrix, after the process has been done, we'll get a Z1, Z2, Z3, and based on the number of words, number of tokens, we'll get the Z vector, and those Z vector is being passed into a feed forward network. You guys know about the feed forward network where the direction will be in one single direction. It will not be coming back. So this is Z1, this is Z2, this is Z3. I'm going to have two hidden layers and I'm going to have three output neurons that responds to R1, R2, and R3. So after this process, you could be able to see R1, R2, and R3 will be up. So this is the output of first encoder, and after this one encoder provides the R1, R2, and R3. This R1, R2, and R3 will be pointed to the second encoder, say encoder number 2. And after the process, you will also get R1, R2, R3 from the second encoder, and this output will be passed as an input to the encoder number 3, and goes on, goes on, goes forward. So based on the number of encoders what we have, it will be going on to it. So now let's talk about how does it works. Okay, so let's say what is happening inside the self attention now it is being passed into the what we say feed forward neural network. So now we do have an input word. I'm going to just talk about the input word right now, then in the next consecutive part let's talk about how it is being formed as a matrix to point to out. So now first an input word where we do have an input word like this, say it's J O I something stuff like that. I'm going to do the embedding as you guys know in the first step before self attention task. we'll be doing the embedding. Say I'm going to convert this into an associated numerical values. Once the embedding is done, we're going to generate three important vectors, say Q, K, and V. This Q, K, and V stands for this Q, K, and V stands for query vector, key vector, and value vector. So even if you go check any kind of generative AI courses, you could able to see the basic stuff behind the QKVs as well. Query, query vector, key vector, value vector is nothing but the first step behind the what I say in behind the encoder. So we'll get a query vector and we'll get a key vector and we'll get a value vector. And for those query, key, and value vector, you'll be having an learned weights. Okay, so you'll be having a learned weights. I'm sorry, guys. So you'll be having a learned weights. I'm just writing QKV. So this Q vector, this K vector, and this V vector will be having another set of learned weights. Say a learned weight will be there for each and every K, Q, V value. So, which is WQ, WK, and WV. So, this is the first step. But why? Because we said this is only for one single word. But we said that for each and every word in one particular sentence, what we are supposed to do. In this case, we're going to set up a matrix formulation. So, for each and every word, say this is x1, x2, x3. These are the words in the sentence. We would be having an embedding for this. Say we do have embedding 1, embedding 2, and embedding 3. Once the embedding 1, embedding 2, embedding 3 is done, we are supposed to perform three important things, which is query. First of all, we'll be having the query vector, which is pure query matrix, query 1, 2, 3, which consists of those things. Then we'll be having key 1, key 2, key 3. Followed by that, we'll be having another values called as V1, V2, V3 with the associated WQ, WB, and WK. So far so good. You might understand what we have done. So the next step, right? This is the step number one inside the encoding in the self-attention point of view. In the second step, what we're gonna do is that in the second step, what we're gonna do is that say I'm gonna take a softmax. Okay, I'm gonna take the softmax. As you guys know, softmax is nothing but a classification activation layer used in the machine learning perspective, more sophisticated in the deep learning perspective for find the probabilities based on it. So I'm going to use a softmax to find this softmax is placed around the q values and the k transpose, which is the key value, divided by square root of dk, where the d depends upon the number of entries, say the number of words in the sentence, times of value, which will give you the z. So this z for each and every q, say it is q1, k1, v1, we'll get z1, z1, z2, z3 will be automatically generated. So now you guys know the basic behind how z1, z2, z3 will be built upon. So this is what the calculation called as QKV matrix. Okay, this is what the calculation behind QKV matrix, finding the softmax of Q times of K for softmax of query times of key transpose divided by square root of dk into value matrix. Okay, so this is how it is being formed. Okay, now let's talk about, so this is what we could able to find the z1 z2, then we can able to pass the z1 z2 into the feed forward neural network to provide the automatic stuff. Now let's talk about the encoder-only architecture models, decoder-only architecture models, and encoder-decoder architecture models. Okay, so to give you a basic understanding, encoder-decoder architecture model example is BART. Encoder-only architecture is BERT, which stands for bidirectional encoder representation from transformers. And finally, decoder-only, we could able to take an example of GPT-2 and GPT-3. So what happens in the encoder, the opposite things is going to happen inside the decoder to provide you the point of view, right? So this is what the basic stuff behind the what may I say, transformers and the encoder-only, decoder-only, encoder-decoder architecture. Now let's talk about what's been cooking inside AWS. So this has been already released in the what may I say AWS reInvent 2023. There is a three-layer of generative stack, starting with the infrastructure for the foundation models. Say we need to provide the infrastructure based on the training and inference model size and parameters point of view. So where we need to use the training inference, inferentia inference, from inferentia inference, neural SDK to provide those things. Today we're not going to talk about that. Today we're going to talk about the second thing where the tools which is used to build with the foundation models and language model models. A fantastic service which is called as Amazon Bedrock. We're going to have a look out of it. And thirdly, we're going to see what are the applications that leverage the foundation model. Say if you're going to have the if you want to have an application, we do have an application in AWS called as Amazon Q and an AI powered assistant which has been fed up with the AI docs, and you also have the code whisperer which can able to generate automatic code responses to the particular prompt which has been given to you. So to give a basic behind the for Amazon Bedrock is a fully managed service. It's a serverless service which is used to access your high-performing foundation models. Say you want to access your foundation models from the leading AI companies from A121 Labs, Anthropic, Coher, Meta, Mistral AI, Stability AI, and Amazon. Amazon also providing some foundation models with one single API call. With one single API call, you can able to access any kind of models, but make sure that the body of each and every model differs based on the body you are supposed to provide to it. Now, so this is being already list, but I want to show you the basic stuff behind it. So what are all the broad choice of models available in Amazon Bedrock? So starting with the Jurassic models, like Jurassic 2 Ultra and Jurassic 2 Mid, which is used for question answering, text generation, for searching the keys from the document, say from the text and summarization. We do have it from A1 to Labs. So the maximum number of tokens which should be given to the model is 8,192. Followed by we do have Coher model, say command line, and we can also use it for embeddings, like as I said, the embeddings topic. So embeddings can be done in both the languages, from English as well for multi-language, which can be used. And these models can be used for chat, text generation, stuff like that, with the maximum token size of 4,000 and parameters of 52 billion parameters with the dimensions of 1024 for embeddings. And third thing is my favorite thing from Amazon with Titan Text Express, Titan Text Lite, and embeddings is also there, image generation is also there, and which can be used for RAG too. So we're going to perform RAG in the next consecutive series. And Distill, so one of the famous model right now, it has been booming right now because it's a very lightweight, very high efficient model, Mistral 7B, Mistral 8x7B, which is used for text summarization, structurization with a maximum token size of 8,000 to 32,000, and Llama 2. So Llama 2, 13B chat, 70B chat, and two more things also been released, like used for dialog use cases. The maximum token size is 4K. And Anthropics. So for Anthropics, the Claude 3 Opus, which has not been released yet, and Claude 3 Sonnet, Claude 3 Haiku, which was released recently, which is can be also used for a lot of use cases. And finally, Image. So Stability.ai company released two important models called as Stability Diffusion XL 1.0 and Stability Diffusion XL 0.8, which can be used for image generation with the help of the prompt which being given to it. Right, the maximum token size is 77 to the token limit of the prompt will be given to accordingly to it. Now let's have a look, right? Let's have a look at the Amazon Bedrock Console. So this is nothing but the Amazon Bedrock Console, and you can able to see that Amazon Bedrock is not available in every region. Amazon Bedrock is available in one in specific regions only. Make sure that I'm right now in US East one in Northern Virginia. Right now the service is available. I would like to show you the. You can able to scroll down. There are a lot of options. We're gonna show you a lot of options today. The first thing is model access. Like you are first before starting right working with generative AI, you are supposed to access the model from the Amazon Bedrock console. So you have to request the Amazon Bedrock that I'm going to use this model, stuff like that. So you could able to see all the other models are provided, which has been provided for me. But Mr. Large's new one, I've been asked for the request, and these two also the new one. And for plot tree sonnet, like for the anthropics models, you are supposed to provide the use case, like for which use case you're going to use the model. Like it includes stuff like you can able to click manage model access and click submit the use case details, which will ask you the company name, stuff like that. So this is how you can able to access a model before doing any kind of stuff. First, access the model for your account so that we can able to use it wisely, right? So let's go for the playgrounds. These foundation models will give you the custom or base models which are available, and what are the examples which can be used for each and every models. Let me go for the playgrounds, and let's what can I say, do three different type of options. First thing is a chat, second thing is text, and third thing is image. Let's ask the model. Let's take the Titan Text G1 Express model to take the meeting transcript and provide a list of action items for each and every person. You can able to see this a dialogue which was given to the model, and ask the model to run the meeting transcript about create the list of actions from the each script. I'm going to run the model. Let the model think, let the bot thinks, and just say so here's the list of action items for each person based on the meeting transcript. Say Miguel wants to do those things, Brand wants to do those things, and Namita has to do those things. So you could able to see the model metrics below, and you could also see some configurations like the parameters of like the things called as temperature, what can I say, temperature, top P parameter, stuff like that, right? And this is the text model, like text breakdown, where you can work with those things. I would like to work with advanced QA with citation, but it's a huge document. But let's start working with some kind of use cases. You can also use this playground and start working on it. Let me go for the image and then ask the text, write an image generator to generate the image. It will take some while. I just given a prompt like a blue backpack on the table. It provides me three variations of it and tries to provide it. But make a note that these images are generated by AI model, and you can also use the next option available in Amazon Bedrock, which is called as watermark detection, where with the help of the watermark detection, you could able to find whether the image has been generated by Amazon Titan image generator or not. Okay, you could come back over here, choose an image, and start working behind it. Okay, so sorry, I reset it back. I don't want to use it right now. And these are the knowledge bases where you can create knowledge bases. Say you're going to working inside an organization which has a lot of documents. Say the product list, the product features, where the customers want to know about the features of the document, but they don't want to learn the entire thing, right? So we need to feed the knowledge to the document. So say what we can do, as we already know that all the foundation models are fed up with huge knowledge base, right? So instead we can able to create our own knowledge base and put it over to the model so that the model will learn the things. So we're gonna do those things in the next consecutive point of view, and these are the agents, right? So I'll delete this agent because I've created a long back. Let me delete this agent, and so this is the sample agent what I've been deleted. So sorry, what has been there already. So what you can do is the thing where whether the user input, and I would like to say whether you want to do something else extra stuff like that. So like I'm going to give you an overview about the agent. What agent does is nothing but agent will do automatically. Okay, so what happens is that agent will choose the foundation model, does the jobs and provides output. As a user, we don't want to choose the AI model, right? Agent will choose, it will run the AI model, run the foundation model, and extracts the output from it. And this is the model evaluation. You can able to evaluate the model, and finally with the provision throughput, which will allows you to have a dedicated capacity to deploy your models, right? So this is all about your Amazon Bedrock, right? And I hope I've given you the basic stuff behind the transformers, and we also showed you the basic stuff behind the Amazon Bedrock, right? So you can connect with me in LinkedIn. I'm in LinkedIn, so you can connect with me in LinkedIn. So my name is Rahul Gopal, and you can connect with me through LinkedIn here, right? And followed by, you can also send me a message if you have any doubts in this session, and you can comment, just give your open comment so that what are the things to be improved, and we can be able to take that and move forward to the next consecutive generations, just the next consecutive series. Okay, okay, guys. Hope you got something new from this today's session, and thank you guys for joining today, and hope you learned it new. So let's see in the next consecutive series. Thank you, everyone, and have a good day.